Hi everyone, welcome to step 6, which is going to be connecting the output of these logic gates to the inputs, the digital inputs of our decoder chip, which we can see the output on there. So at the moment we have these currently being held low, and this is just as a testing measure, and we're able to change those by connecting them temporarily to positive to change the value of the binary number that's on the input of this, which would then, when we strobed it by pulling this input, blanking and store input pin low, that refreshed the number that was going to be displayed. So now we're going to use the actual logic from our chip to do that function for us. And so what we had here is this group of 3 diodes here. That's going to be our 1s. Okay, and that went to pin 7. Okay, so pin 7, so all the way over here, has to connect to one of those. Okay, now, how to do that? Looks like I had a longer bit of breadboard wire there at some point. Oh, I wonder. Okay. All right. So what I'm going to do here is another little trick. So because this is quite a long connection, that's, about 6 or 7 centimetres, rather than having one giant big connection like that, I'm going to use 2 smaller connections and this rail at the bottom that we're not even using. Okay. So what I'm going to do, it's the second from the bottom, not the very bottom. I'm going to use that. So connecting that there to there. So the where the resistors connect to the diodes, that we would call the output of our logic gate or logic circuit there. Okay, and so what I'm going to use for this is just another bit of breadboard wire. Might need to make up another bit. Let's use that one. Okay. It's important to remember what it is we're actually connecting to what there. And so it can get a little bit confusing, but so what I'm trying to do here, so pin 7, so pin 7 of our gate is connecting to the red rail at the bottom here. Okay, now making sure that we don't accidentally touch them to either of these other ones. Okay, and that then is connected to the output of our logic gate, which is up here. Okay, and it just saves us having a great big long messy piece of wire that can cause problems going right away. Now we don't need this resistor anymore, so I'll just remove that. I should probably actually disconnect the power supply before I keep doing this stuff so I don't accidentally fry something, because it can happen. Okay, the next step will be connecting the 2's output, so that's this middle 3 diodes, so middle logic gate, and that connects to pin 1. Okay, and that goes to here. Now I'm just going to use a piece of breadboard wire for that. And I think I had this one the right length. There. It's a bit long, but it's okay. Okay, so this is a bit long than my usual ones because usually I try and make them all nice and flat. That's out of the way. Right, so pin 1 goes to the middle one, and by process of elimination, we can probably figure out pin 2 goes to the next one. So just again, that one there, just that one there. Okay, so I've got a bit of a crossover there, but that's okay. Just got to make sure we don't accidentally touch any of these input pins together. Right, so now what we should have is our an actual function, more or less functioning random number generator, which if I use a bit of breadboard wire, I should be able to touch this on here. There we go, so display to 3 that time. Hopefully, yep, there we go, go to 4, hold down for a bit longer. Okay, seems to be some problems. I wonder if it's related to what I had before. There we go, that seems to be doing a bit better. We've got 6 at 2, 3. Okay, so we've got ourselves a functioning dice. It's just not going to be quite what we have. Well, to finish it off, we need to have it so we can interact with it relatively easily rather than having to fiddle around with a bit of breadboard wire. Okay, so we are 99% of the way there. We've only got one more little bit of circuitry to go. And that little bit of circuitry is a transistor switch. Now, the reason why we use a transistor switch is so that a transistor only needs a really small amount of current into the base or the controlling pin of the transistor in order for it to switch a larger amount of current. And we're going to be using that, well, it's not even going to be very large amounts of current anyway, but we're going to be using that to control the logic level that is on this input pin that we've just been controlling with our bit of breadboard wire. So the way that we're going to set this up is my transistor here, it should say BC547 or 548 on it. Okay, and we connect that into our breadboard, and if we place it this way with the 3 pins side by side and the flat side towards us, then the collector we're going to connect to the positive with a resistor. The emitter, which we're going to connect to the 0 volts with a piece of breadboard wire. And then the base, we're going to use that as our touch. Okay, and so I'll just set this up, just disconnect the power supply so I don't accidentally ruin something. So one bit of breadboard wire, one resistor. Now the way I'm setting this up, I've bent the resistor so that it's bent right over right next to one end of it, and I've left the really big long lead and bent over at the end. And the reason for that is I'm going to be touching that lead as part of my touch switch. Okay. And I'm going to do exactly the same thing. Now this is a 100k resistor here. I'm going to do exactly the same thing. It's just a little bit shorter, and connecting my resistor to the top part of this breadboard, and that gives us quite a bit of wire that we can use to touch. Okay, so you can see here we've got quite a bit of wire there. All we need to do is just put our finger on it and touch both of them, and that's good enough connection to fully switch on this transistor. Okay, and the final step is to connect the output of this, which is the left-hand side pin of the transistor, which we call the collector. That connects to this pin that we were controlling before. Okay, so just bend the wire so it's more or less right, and put it over there. And now we can remove that temporary resistor. We don't need that now. And fingers crossed, we've got ourselves a functioning dice. There we go. That's I'm reasonably satisfied with that. Okay. Now remember earlier I was mentioning an issue with having just this one resistor here on the LED on the 7-segment display, and that's because when we have lots of LEDs being lit up. So for example, we've got there's 5 LEDs being lit up for number 5. It's going to be a bit dimmer because it's got to share all the current between those LEDs than if it was a 1 or something with fewer LEDs being lit up. So let's see if I can get a 1 there. That's the brightest one. There we go. Oh, there we go. Okay, and you can see that one. Well, I'm hoping you can see it on the camera. Is quite a bit brighter than the other numbers are. Okay, and that's because it's only got 2 LEDs lit up, so less current has to be shared through that resistor, and so they can be brighter. And that's the finish of this project as far as what I intended for you to work at home. If you make it into the classroom in the next a few weeks, and you finish this project, what we can do now is we can actually commit this to a printed circuit board. So we can design a PCB and then etch it and have a functioning circuit that you can then actually, it won't be just on breadboard, this is a bit kind of flimsy and prone to error. And so yeah, we can have a more robust and well, admittedly better looking, I think, circuit that's built for you. And then we can house it in a box and do all that sort of good stuff. Okay, well thanks for watching and good luck with getting this working.